Welcome to the ET302 how-to video for the series Parallel Lab. Here we are at Multisim, so let's go ahead and find our files. These I'm providing for you, so put them somewhere like the desktop or somewhere where you could find them. And and I'm going to start with 7A. And that looks like it. So what we're going to do is we're going to attempt to fill out our chart. And we have circuit 1, 2, 3, so we're going to go through and change these. So we're looking at the branch. Okay, branch A, branch B, and total resistance. So let's start with total resistance. So let's open this up. First off, let's zoom in. And let's turn on and open up our meter, and let's put it in resistance, and we have 1 ohm. And the secret to these is if they're the same size, let's add them up. 1, 2. So if you have 2 ohms in parallel, it's going to be half of one of these, so it should be 1 ohm, so it checks out. Okay, so let's shut it down and let's do this branch and start, and we should get 2 ohms because we have 1 branch. Shut it off, and we're going to move this guy. So you see there I've got a flag with an X and some tail on it, so let's do that, and let's start it up, and again we get 2 ohms. Okay, so basically what we're going to do is you're going to change the resistance of these branches. Okay, so let's go ahead and finish this guy up, and we're going to do the next total. So we're going to change all these to what I say in the chart. So 2, 2, 2, 2. Okay, so we have our new circuit. And again, we have 2 plus 2 is 4, so we have 2 equal branches in our parallel here. A series parallel, that's 4, and you divide it by 2, so we should have 2 ohms. Good. And if I wanted to change this to K, I'll just show you that real quick. And this one's not going to let me do that, so we're going to have to go to replace. And let's go to basic, resistor. Oh, that jumped right to 1K. How about that? Let's do that again. Replace. And we want 2K in this case, maybe, so we just go down and pick 2K. Good. So that's pretty much this entire lab. Okay, here's the circuit that it's supposed to be as it is in the lab. So what we want to do is I want to keep changing this file to be equivalent. So here we have 6 and 2, that'll be 8, and 4 and 4 will be 8, and 2 and 2 will be 4. Okay, so now what we need to do is make the equivalent circuit. So we have to go through and calculate a parallel circuit here. So we have 8 inverse plus 8 inverse plus 4 inverse equals, and I come up with 2, so I should change this to 2, and these should be all equivalent when I turn on the circuit. So this one should say 20 volts. Well, that's going to be 20 volts. And this should be 20 volts. And this should be 20 volts. And let's change this to current. And our current should be the same. And it is, so what we have is the equivalent circuits. All three of these are identical since we have the same complex resistance reduced down to the 2 ohms, and we should get the same current. Okay, let's build our circuit, series parallel circuit experiment 1. So we're going to need some components, so let's grab some resistors. And we're just going to grab them. We'll change the value. We just need to make sure we put them in the right place. Let's go back to sources. So we need a ground, and we need DC power, and that's all. So let's zoom in, zoom area, oops, yeah, zoom area. All right, so let's move him over, move our ground down, and R1 goes right here, R4 goes down here, and R2 goes here, and R3 goes here, and we're going to rotate this guy 90, and we're going to rotate this guy 90, and then we're going to connect everything. And we have it. So now let's change the values. This is going to be a 1. This is going to be a 2.2. This is going to be a 2.2. And this guy's going to be a 4.7. Okay, that's good.